And again, it's going to be have quite a lot of pictures, and I'm hoping, like previous times, that students will make notes and ask questions. It's much more fun if we get a bit of interaction. So what I'm going to cover is really do a very quick run through of some of the different types, the typologies, particularly to do with materials that you find across Southern Africa. We've got many different climatic zones, different tribal groups, different materials. And you can see in that fairly quick run through some quite interesting examples that we will look at. What I'm then going to do is look at common space, how space works in villages and in yards, within houses themselves, and look at how social interaction happens. And that's quite important really for this competition, because you may be accommodating a whole range of different cultural groups, different people from different areas, and you need to tackle how space and structure works. What I'm then going to do is look a little bit at traditional construction and dive into that a little bit. And then what has been happening is that a lot of the kind of traditional construction techniques and ideas and principles have been evolving. So if you look at a lot of traditional villages, they now have quite a lot of modern buildings, but there's a lot of principles that have remained, that have worked very well. And it's very interesting to see how they've been evolving. And then the last thing I want to talk about is why this is useful in terms of sustainability performance. What are some of the kind of key things that you can learn from Indigenous architecture? So running through different types fairly quickly. So this is an example of a traditional house up in Maun in Botswana, up on the Delta, made of reeds, very simple, very quick to build. The climate here is generally fairly warm throughout the year. So there is very simple, straightforward materials, all sourced locally. This is buildings from Madagascar, and you can see more robust construction, more timber, again, to withstand higher winds, but again, big overhangs, very simple, locally sourced materials, and quite elaborate designs. This is from Namibia. So much hotter climates, and the key issue here is shading, but also mobility. So the ability to take these large bent structures, put matting, reed matting around it, and all of this can be dismantled, in a couple of hours and transported. So as grazing changes, as families and groups need to move, the buildings can move very easily. And again, bio-based materials, using local skills, very straightforward, simple construction, but very effective. So shaded spaces, and comfortable for the climate. Similar type structure, but more permanent. So this is Swazi structure, large curved timber members, and then thatching, and then a netting over the whole structure to keep the thatch in place and intact. Also, Swazi structure. So this is a lath and plaster type structure. So using poles, again, sourced locally, and then either using hard lumps of clay or stone, in between the laths, and then that's plastered, and you get a very robust structure which uses local materials, and this would then be thatched for again, thatched using local grass. Moving into colder regions, so this is up towards Lesotho, so stone buildings, much thicker walls, so better insulation, much thicker thatch, smaller openings, there would often be a fire inside, and then there would be perimeter seating so people can sit outside when it's sunny, warm up, and move around the building as the sun moves around the building. But again, all local materials sourced within, 10, 20 kilometers from the building. This is in the Eastern Cape. So again, quite a big, some of these rondavels are quite big. This one's a modern one. It's painted with modern paints to make it a bit more waterproof, so you don't have to smear the building regularly. There's a stable door that allows light and ventilation into the building. And one of the traditions is to put a tire on the roof somewhere so that if lightning hits the building, it'll bounce off. And again, very robust, well designed buildings that respond to local climates. We're now moving into Botswana. So this is near Soroe, very hot climates, and the building is kind of tucked into large trees. There's a little lolwapa, little yard in front of it, and you can see the markings done in ochre and with cow dung. So there's a lot of use of different soil types to provide patterns and keep the buildings in good condition. What we're now going to do is having run through the different types, is stand back a little bit and look at some of the characteristics and what we can learn from indigenous architecture. So this is a large village in Botswana. And what's interesting about it is that there are no particular streets. So the way the settlement works is that people have their yards, and then there's open space. So people can move very easily and freely between spaces, and generally watercourses and hills won't be built on. And this works very efficiently for water movement, so it's very easy for water flow, and there's a lot of porous surfaces so that you don't have the issue of flooding, and it's very well integrated with nature. A lot of trees, natural topography is actually just left as part of the village. And what's interesting is the way vegetation is used. This is Muromotala. It's a hedge which is often around people's yards. It provides shade, provides protection against cold winds. It can also be used for football pitches. So in this particular case, it's a way of protecting the football pitch from people, and then you can charge because it's so thick you can't see through it. So if you want to go and see the football match, you would come through this entrance and pay a small amount to go and have a look at the football match. And you can see how thick it is. So very thick hedges, and then this open space in the middle. So we're now moving to a kind of traditional yard. And again, this is an extremely dry area. It's up towards Soroe, Shoshong. And you can see around the perimeter, there's a fence, and then you've got the huts and the lolwapa. So there's always these two layers in terms of spatial structure. And often some larger trees are left in place. And so you can see the structure drawn here, where you have the outer perimeter. There's an entrance, and then you have the lolwapa, and then the more important house, the less important house, and then activities at the back of the yard in terms of things like where animals are kept, toilets, cooking, etc. So moving into the actual structure, this is what the huts look like. First, often a timber structure will be built using trunks of trees sourced locally, and then often the men will build this and thatch it, and then the actual mud structures would then be built and plastered underneath this. So you can see that's the timber structure, and then you have the mud wall set behind it, and the internal structure here. And these are the spaces inside the house. Just in terms of the structure, the structure works very effectively for the climate. So summer climates are very hot, the sun is overhead, you have a very nice big overhang, you can sit outside in the shade, and there's also a gap at the top of the wall where you can get good cross ventilation and airflow through the building. In winter, what happens is that you get low angle sunshine. It hits these high thermal mass walls, they warm up, and when the sun goes down, these walls are warm, particularly the kind of west facing walls, and that re-radiates heat into the room, and those rooms are nice and warm at night. So again, very comfortable, well-attuned buildings. And with these buildings, again, all the materials would be sourced locally. And that's why particular branches with forked tops would be selected, and the families would go and source the different materials, bring them back, and within 2 to 3 weeks, the full building would be built using materials sourced locally. So what's happened over time is that as people have seen more modern square buildings, the designs have evolved. So you get these slightly larger buildings with verandas. A lot of the principles remain. So there's still the lolwapa, there's still the outer fence, there's still the area that you can sit on, you can socialize, you can warm up in winter, and that protects the walls also from driving rain. So a lot of the kind of traditional principles remain in these more evolved modern buildings. So we can run through now and just look at some examples. So again, this is Nyeshoshong. So there's an entrance, you come into the entrance, and one of the things that families have done is obviously brought in some technology. So there's radios, solar lights, which get charged. You have the lolwapa here, and the building, one of the buildings here. So you can see the very large overhangs for shade. Another view showing that space, again, where people would sit, where more important visitors would come, where some of the, like a wedding ceremony would be happen in some of these spaces, and meeting visitors would all happen in these spaces. So this is the other hut, and again, what you can see here is the quite large skirting to protect the base of the building. So if there's driving rain, the walls don't erode. It's also somewhere you can sit in shade in summer, and in sun in winter, and the thatching is again materials that are sourced within 10 kilometers of the house. Behind the huts, there would be kitchen areas. So this is made of corrugated iron, and a lot of the cooking, the storage of water would happen here. There would be a toilet. There would be an area for animals, so chickens, goats, etc., might all be kept within the yard and then let out during the day and then brought back at night. So in terms of maintenance, what's very important is each year the walls are re-smeared so that you protect the walls against driving rain. And this is what's happening here, is that clay, ash, cow dung would be mixed, and that would then be smeared onto the walls in late winter, ready for summer rains coming later. And you can see that smearing has happened here, so you get this very nice effect around the buildings. This one hasn't got markings. Many of the others would have markings and patterns on the buildings. So what's also very important is just to understand the kind of spatial structure. So you come from this outside space, you go through your first entrance, and if it was a formal visit, you'd then go to the Lolwapa, you'd meet occupants, that's where you'd sit, you'd chat, talk, and that's where you'd be entertained. That's where discussions would be. If you're very good friends, you might go round and you might go to the kitchen, you might go under a tree and have discussions elsewhere in the yard. And so deeper into that yard, there would be storage for granary. There would be shaded trees where you might sit when it's very hot. There'd be a kitchen, and a lot of activities would then happen in that open space. But the more formal Lolwapa area would be where a lot of the social interaction, more formal things would happen, and it would then also be where different members of the family would sleep, and there's a structure in terms of who sleeps where and how that works. So what is interesting is to see how this is developing. So many of these villages are turning into towns, and they started off with very dispersed yards, and over time these have grown as people move in. The yards have started joining together, so you get what's starting to look like an urban settlement. And what's important here is to also think about this in your competition and think about how your settlement might evolve. It's very unlikely that perhaps you get all the funding at once. And what you might want to think about is the kind of evolution of space, the evolution of settlements to fit and work with what's happening in society, in the local economy. What's also interesting about Indigenous systems is how the financial systems work very well with people's circumstances. So a lot of these households may have one member of the family who may work, for instance, in a cattle post, in a mine. They might go to the city, and they earn amounts of money which they can save throughout the year. And so what they would do is use these savings to every 3 or 4 months buy materials. So you accumulate a whole set of materials such as concrete blocks, corrugated iron materials, and then when they reach a longer holiday or a particular time of the year, they might employ a builder, they might employ some of their friends, work with their friends, and then build that extra room. So in a very incremental, simple way, you can build fairly large houses without having to go to the bank. So you can avoid the interest rates and the whole complicated issues associated with banking and bonds. And you need to think about the financial systems because many people's circumstances are not attuned or aligned with the bank's requirements. The bank will say, we want work contracts, we want bank statements, we need a salary at a certain level. And if your household doesn't have that, it doesn't mean they can't build. You need to kind of think of models that enable them to build. So there's some very interesting models that you can find around Indigenous knowledge systems and kind of evolving building processes. And you can see how this happens, where different elements get split up. So you might build a shell first, then you add windows, add internal partitions, then maybe add plumbing, and then finally put in some furniture, fittings, etc. over time. So that might be the order, or you might work from one end of the building through to the other end of the building. So you can think about a kind of sequential process of building, designing and building structures to align with how families' finances evolve and their needs evolve over time. So the last thing that I want to say is that I think the important thing is to see how these processes have evolved. So if you look at informal settlements, many of these ideas have come through in informal settlements. So the idea of these very simple structures that can be added to and change over time to fit requirements. You get entrepreneurs who build modular buildings, and those can then be established very quickly within a couple of days, and a family or a couple or a single person can evolve and develop that over time. And the tools for that are often very simple, might be hand tools, and the scale of the materials, the weight of the buildings, often something that you can lift fairly easily, can fit into the back of a bakkie, and you can get a building very quickly and at low cost. So the last thing I want to say is, if we think about all of the typologies that I talked about right at the beginning, in terms of adobe construction, stone, wattle and daub, timber and reed, woven timber, and then kind of conventional concrete structures, you can think about how they perform in terms of some criteria. So do you need skilled construction skills? What are the maintenance requirements? Are they very high? Are they very low? What's the lifespan without maintenance? How responsive are they to the climate and the site? How well do they work with people's and families' financial situation? Do they align well? Do they work well with people's financial situation? Are they responsive to the local economy, environmental performance, in terms of comfort, use of energy, social performance? Are they aligned well with culture, social interaction, action, and kind of how people want to live in the particular area? Building compliance in terms of regulations. You'll find there'll be many problems with traditional buildings and regulations. Self-build. Can the construction method be built by someone without formal training? So how easy or difficult is it to build, an adobe construction and thatch a building? And then emergency housing. So one of the things often that happens is that, if you need to build very quickly, how suitable are the different construction types for that? So this just gives you a kind of quick way of thinking about some of the different methodologies, and how you might want to draw on some of the principles and evolve some of the construction types, the spatial types in your thinking and competition entries. I think that's me. Thank you.
Thank you so much, Prof. Jeremy. It was very interesting to see how this week's your thoughts this week ties in with your thoughts last week. Thank you so very much. And then up next, we have from the NHBRC, Isaac Hartley. Isaac, are you ready to share your screen? Isaac, if you can unmute yourself. Isaac might be getting a package at the door or having trouble with the unmute. While we are waiting for Isaac.
Yeah, no, can you hear me now?
There we go.
Let me just,
Isaac,
my camera, let me switch on my camera. There's me.
Hello.
Yeah, I think now, my name is Isaac. Thank you for being here. I'm working for the NHBRC, which is a division of Department of Human Settlement in terms of regulation. So we regulate the home building industry in terms of sustainability, you know, and other matters related to it. So it's a very great pleasure to be presenting here, especially to the students, because I normally deal with innovative technology. And I like to concur with Professor Jeremy's presentation. It says a lot. It talks a lot about what I normally deal with on every day, how to combine indigenous and bring innovation to it. Because without indigenous, there's no innovation. So students should just look at, because what I'm going to talk about is what Professor was showing us, the shading, the supporting, the structure, and the architecture. So my presentation will be addressing some of those things to say, what did we do right in order to be where we are, in order to bring a technology? So I will be going to my share screen. Can you see it?
Fantastic. I'm taking a look. I'm checking.
Yeah.
I can't see it yet. Jeremy, can you see the share screen?
Just try sharing again from below. It might take a little while just to show.
Oh, okay. Let me just go to. Let me just go to share screen.
There, something's coming up. Fantastic. And in the bottom right, if you press presentation again.
Presentations. There we are. Yeah,
perfect.
Now we can see the first page. Yeah.
Perfect. Thanks, Isaac. You have the floor.
Yeah. So on my presentation, I'll start with the legislation, because students need to know why we're doing this, why sustainability, and so on. The focus on compliance to the current regulation, because everything that we do should not violate people's rights and should be in good faith with the law. So if we look at this article, it's a human right article that says everyone has a right to have a standard. Before we go anywhere, a certain standard is emphasized that is adequate for the health. I think Professor Jeremy talked about how the walls heating up and so on, of the well-being of a person and his family, including the food and so on. So whatever we do in terms of housing, we need to make sure that we address the issue of a standard of a living in terms of the health of the people. Now, when you define what is it that is adequate, when you say adequate housing, South Africa is a member of the National Assembly, International Assembly. So it subscribes to the issue of adequate housing in terms of the habitat declaration. So as a student or as a learner or as a person working within housing, you need to think about the services, the materials, tenant security. In case you want to move, you want to sell, you need to think about affordability. You need to think about cultural adequacy, of which is what Professor was elaborating on. You need to think about accessibility in terms of disasters, as you have seen that the houses starts as one, and then in time they grow. There is not enough, maneuverability, streets and so on. But in case of disasters, you need to think about accessibility to those houses. Location, are they located closer to amenities? Is there any activity around the settlement? As you've seen, Professor Jorma was talking about a soccer pitch that has been fenced. So you look up around those things, and then you look also around the issue of employment opportunities. So this competition, as it goes on in Eastern Cape, those are the things that we know going to look into. The students need to focus on all these matters when they come with innovation. You can still design and do beautiful using traditional combination of, but what is important in terms of South Africa, because if we check the Constitution in terms of Section 26 says everyone has a right to have access to adequate houses. So the word adequate is been explained more, is been mentioned on many times. Now, we say a house is not adequate if it does not have physical safety, protection against heat, damp, cold, rain, wind, and threats to the issues of health, and also to structural hazard as you design. So in terms of the Bill of Rights on Section 24, the environment, Professor emphasized more about the environment, the place where this settlement are. But here we refer mostly to not harming the environment, to make the best out of it, to protect it, to preserve it, to remove issues of pollution or ecological degradation, and to promote conservation and to secure ecological sustainability, because all these items, if they are violated, then we're not building sustainable human settlement. So I need the students to look into these elements, because if you look at Act 108 is our constitution. So whatever we're going to design, let it not be a constitutional delinquent. It should form part and try to talk to the Constitution. Now, these are pieces of legislation. There might be more, there are more, but what you need to look into when you're dealing with housing, you're going to look into our building regulations, of which is Act 103 of 1977, which deals with homes which are required to be erected in accordance with the regulations, and the authorities that are involved, what they approve and what they don't approve. But despite Act 103, you still have other acts, you still have other standards, because Act 103 will go hand in hand with SANS 10400. You still have SANS 10182, 082, you still have 517, 163 to deal with your roof loading, wind loading. So you look into the standards that deals with construction in general. But we should address the issue of health and safety. The house should be accessible and be able to protect itself before it can protect the inhabitants. Look into Consumer Protection Act. Whatever we're trying to design will not be against what the consumer is looking for. Look at compulsory standards, your XA, SANS 10400 XA, and all these types of legislation will guide you in terms of designing a sustainable human settlement. Secondly, look at the functionality and the performance. Today, we're having different structures. There's no necessarily need for mass thick building. You can do a very thin structure which can be functional and perform correctly if you do your rational design, and then you make sure that certain materials have been tested to perform certain functionalities in terms of fireproof, water tightness, structural stability. Or you can just go into the Agrima website and look into the systems that have been approved for building walling systems. I'll be explaining more. So we have systems, we class them from category A to category G. You have light building systems, you have hybrid systems, then you have heavyweight building systems. So the student can use any type of system that they wish in order to address the issues that are required in terms of sustainability. Looking at that section 24, that talks about protecting the ecology in line with conservation and so on. So if you go into energy efficiency, this is one of the compulsory standards of which students, whatever they design, they should bear in mind that SAST 10400XA, it's a compulsory standard. Whatever they design should make sure that it complies. It might be a walling system, it might be a building system, a roofing system, a ceiling system, insulation, waterproofing, damp-proofing, whatever materials they use, they must make sure that it will comply with the regulations in terms of climate change. So in coming up with innovative building technology, you have what we call monolithic systems, of which those are systems where the foundation, the wall, and the roof is made of one material. Like you have like an igloo, like a concrete house, whereby the foundation is concrete, the walls are concrete, the roof is concrete. Those are called monolithic structures. Or maybe it's a steel, it can be monolithic as well. Then you have hybrid structures. In hybrid, you've got a combination. It's not limited to two. It can be many, because we've got light steel frame and you've got prefabricated, precast panels. They can be concrete, they can be composite, they can be any material that you may find in the industry. Now, these are the advantages if you're using a monolithic system. As the speed of construction, the solutions provide a speedier housing shortage, so you can address the issue of housing shortage quickly, because the methods are quick to erect. They optimize cost and time. They are stronger against horizontal forces as compared to your normal brick and mortar. You can also use it in terms of disaster management. Let's say there's a disaster, then you can use IBT, of which you respond immediately. They require less equipment, no need for any type of brick blocks that you need to buy and wait for them to cure and so on. The high quality of finishes, some of them, the finish come from the factories, factory made. You don't need to do maintenance on it. The wall or the composite walls, they are pre-finished. The quality of the structure has been tested. The structures, most of them, they are not heavy, they are lighter. So you can use less labor on the material. And in terms of thermal bridges, they are very good in thermal bridges, because the R value of which have been tested is very low. Because if you go to Agrima, one of the things that they strict about it is your thermal bridge. So normally it should be lower than the brick and mortar. It requires few people. Repair and maintenance is very easy, and it's a very high initial investment. It requires special types of materials and framework, and is very flexible. Sometimes if you want to leave a place, people relocate. With monolithic, you can pick up your house if it's of light steel, put it on a truck, or if it's of timber, go and start putting it somewhere. You don't have to rebuild it all again. or you can just dismantle it, put it on a truck, transport it to another place. So the flexibility there is very high. Now on hybrid, these are semi-volumetric, which combines units and panels. This construction method integrates precast structures, of which might be heavier. Some are lighter, especially if you use light steel structure, but some may be cast in situ, like your concrete panels, which you can take advantage of different qualities that makes them unique. So the advantages, it optimizes cost as well. It requires less equipment, no need for bricks again, to budget for bricks again. It's like you can order your house and be delivered. And then the speed of construction, the flexibility in terms of architectural appeal, a variety of options, thermal bridges, you know, but what is important is that it requires training for workers, because precision is very important. If you miss one item, the structure might be dismantled, or if you use the wrong material, with that material, you might have the thermal bridges or other bridges on it. So it's very, very, very important that you train the people working on the system for in case you want to expand in future, and then they know what they're doing. And then the other thing is the type of materials. It might be special, others can be sourced around locally, and it's got a high possibility of water leaking and cracking due to temperatures. We talk about Lesotho compared to Upington, I won't say Botswana, but if you look into the areas of Ganyesa, in the northern part, close to Botswana, those areas are extremely hot in Katu, and you look at the houses in Bethlehem, so there's a big temperature variance. So there might be some cracking and delaminating, especially if you're using composite material. So you need to look into those aspects. So this is a monolithic house made out of timber. These technologies are climate compliance. So you need to make sure that whatever climate that you're gonna put in, as you know, as students, we have, I think, 8 climate zones. So be careful when you put your structures, when you design, is in line with the zone, the climate zone where you're gonna build it. These are some of the examples. You can use logs, you can use timber. I talked about flexibility and architectural appeal. It's up to the students to come up with those designs, you know, give the, you know, a super modern design using indigenous materials. If you look at the house at the bottom, is built with logs, supported on concrete stone. So if you look at it, it's not far off from indigenous architecture. Actually, it is, but modernized, made in a modern way. You still have got your poles, and the whole house, you know, looks in between modern and traditional. So students have the variety to look into. Look at the 2 houses on the right-hand side. We have our brick and mortar, of which, you know, it gives the home the same shape that we used to. If it's not like this, normally we don't accept it. But if you go on the left-hand side, this is an rationally designed house whereby they use different materials in combination. So what happens is that the engineer will source different materials, combine them to bring a rational design in terms of reasoning and knowing the standards of certain material. So this is why I say it's very easy. It's very important that you understand the standards that needs to be applied in certain materials and certain construction and in certain designs, your lighting, your part O, and so on. And then you look at what are we trying to address. You know, the current housing, we're losing 25% of heat on the roof, 35% on the walls, 15% on uninsulated walls. You've got also 15% on your fenestration, I mean on your openings, and 10% on your fenestration. This brings about technology. That's why we need technology to try and mitigate this problem so that we can retain this heat inside the house rather than losing it. If you look at it, it's 100% of the totals that we lose. Now, in order to deal with that, you need to check the embodied energy of any material you're going to use. Where do you source it? Is it renewable? Is it far? The production, does it produces carbon emissions? The disposal, if you want to dispose that material, can you reuse it, or will it create another dumping area that needs to be recycled and so on? So you look into all those materials. What I picked up from Professor Jeremy is that in Indigenous architecture, nothing goes to waste. So try to look into such materials or in your technology. I don't restrict you into going to high carbon emission, but remember the compulsory standards. If you want to use a high, the glass house, then you need to come up with a rational design on how you're going to deal with the issues of heat, low embodied energy, and so on. So you need to come up with a proper design. So the other tools that students should use in order to help them select the materials, because I'll be speaking about the material, you have the Edge tool, which is online. All you need to do is subscribe, and then it will be able to assist you in your design to lower all the costs that needs to be lowered, and then so that you can see whether the materials that you use within the location, is it sustainable or not? What is the comparison in terms of brick and mortar? So the Edge tool is one of the tools that can assist you. There are other tools in the market that you can use. It's still fine, but I think it's very much important that the students at the end of the day will request them to show the difference in terms of why they designed that structure that way. What comparison, what tool have they used to say, I use conventional, in my design is sustainable. If I use this equipment, this barometer to measure, it's equal to the standards, it's not below. Because what we're looking at this competition is that let's solve the current problems that we have. So if your energy efficiency is extremely high, you cannot use that system. It automatically falls out because it's not sustainable. So if you use the Edge tool, it will, give you the barometer, and you go to Agrima, or you use your standards, or you do your rational assessment, because there's a means of compliance of which is your standard, your rational design, which is the reasoning by the engineer or competent person in relating to standard, and you have got rational assessment, whereby you totally don't know the characteristics of the material, but when you test it, it gives you lesser than you would have expected in conventional. So we call it the rational assessment. Then we have performance criteria, which Agrima tests certain materials to make sure that they can perform for a specific purpose. So I want to draw the students to SANS 10400 A20, regulation A20, in terms of the houses, whether the material that they use is suitable for housing, because you find that in A20. So visit your SANS 10400, look into A20 to see that whatever you got from Agrima, does it talk about housing? Because you will find that there is a better material that performs better in terms of water usage and cost, but it's not for housing. So that is very much important. So go to your A20 and check on Agrima, the certificate on the first page. It will tell you the use of that material. So I wanted to draw the students on that. Is very much important. Look into your climatic zone. Look into where the project is situated in terms of this map. This is the at least the latest, if I'm not wrong, which we have added 5H. And if you can look, the climate has changed. If you look at zone 5, of which Pretoria initially it was on zone 2. Now it's on zone 5. So you need to look into how do you design. And zone 2 has moved a little bit lower to the Eastern Cape, of which previously the Western Cape was to be found on zone 5. So it's very much important to look into your design in terms of the climate that you're building. I believe that system Edge will be able to assist you in this regard. Then you have this characteristic to say, okay, fine. If I go to structure monolithic in terms of the zone, thermal performance, hybrid, then you'll make your own comparison. But the aim is not to be below what we have, because we're trying to solve the current problems, not the future problem. We try to solve the current problems to the future, not vice versa. Now, the unit standards, the quality system, we require you to use quality systems that comply to ISO 9001. And in terms of your structures, make sure that you do comply to SANS 160, 160, 13. It's a range of SANS 160. I think it's from 1 to 9, if I'm not mistaken. And also look into your part K, which talks about the walls. But not only part K, you can look into your part L if you're doing monolithic structures, your roof. So look into the entire SAN standards and make sure that compliance is achieved. And then the second thing is the design life of the structures that you will be designing. If you want to do indigenous architecture, no problem. But look into the design life, look into compliance, into the standards, because I can tell you there are indigenous structures which are IBTs. I think I'll show you as we go through, because you can take the old structures and make them innovative. So you look at the materials, you look into your SANS 10400 part A13 that talks about testing of materials and so on, and you look into the design lifespan at least to be 30 years or more. And you look at the objective, the functionality is to ensure that the house meets the preference of the occupants. Professor talked about acceptability. So the occupants should like structures. And secondly, it should not be against their cultural belief and their social acceptability in terms of where they are located. You go to Seruwe or you go to KZN in the Tugela area, you know how the people in the Tugela area build. So it should talk about ecology. Remember my second slide that talks about the act and the ecology and the ecosystem. So look into those elements. A good example that I'll give is when you fly to Eastern Cape in Mthatha. Before you land, you'll see all those houses. They're all the same, beautiful, round, with different colors, but the architecture is the same. So you can see that those places, it talks to the ecology, it talks to their culture, and it talks to their social needs as well. So those are the things that we should look. If it's an urban, let it look urban, let it talk to social acceptability, let it talk to the urban culture, as you know that urbanization is the key now. I don't say students should always stick to indigenous. No, if you come to smart cities, think about smart city. I'll give a good example. Sorry for wasting your time. If you look at the Johannesburg waterfall smart city, it's built with monolithic structures, of which is your sheeting, and the bigger houses are built with a combination of rational design and hybrid systems. But there are fewer houses that are built on brick and mortar. So for the ease of your competition, visit smart cities. Look how they design smart cities, the functionality of smart cities, then you'll be able to deal with the matter. I like this structure. I saw it on Professor Jeremy's presentation. I normally tell people that innovation starts here, because now from here on, that's where we started moving, knowing how to reinforce, how to roof, because we can use any material here. You can use thatch, you can use tiles, you can improve this to use shingles, you can use this to use concrete tiles. You know, the walls can be cladded, they can be plastered, a whole lot. But indigenous architecture, if you have listened to what Professor was talking about, it gives rise to innovation. So this talks about the entire innovative building technology. So you have a base where you can start your presentation. I mean, your items of the competition. You've got your indigenous, which gives you knowledge to say, where did it start? Then you've got your innovative tools. You've got your edge. You've got your smart cities. And then you've got technology itself, materials, and all those elements. Then they will assist in bringing up sustainability. More importantly, do not violate the Constitution. Thank you.
Isaac, thank you so very much. As last year, that was extremely interesting. I'm going to open the floor for any students, lecturers on the call. If you have any questions, raise your hand or unmute yourself. We are here to hear them out. I must say, it's interesting to see that most of the students and lecturers are obviously accessing the videos afterwards, after we've posted it. But for the group or two groups of students that are here, there will be 12 prizes. So if there's only so many students taking part, all the better chance to win a prize, all the better chance to be successful. So yeah, it might result in less submissions, but more prizes for those, you know, who submit. So any questions or comments?
Francine, I think while we're waiting, Isaac, thank you for a very good presentation and kind of run through of the key issues. Just to mention, I think your website has quite a lot of information on IBTs, materials, etc. I think there's some guidelines on there. There's energy efficient designs. There's, I think, accessible designs. I remember there being a few, so disabled access, accessible housing. Maybe just mention some of the resources that you have, because I think students can also go to those and download them if they're interested.
Yeah, students can just go to our website and go to IBT to show them a database. But the database, I'll prefer them to check Agrima SA database. It's got the latest systems, because remember, some of ours have not been updated in some time. And in terms of Agrima, some are shelved, some are active, some are inactive. I should have shown them what an active certificate looks like, but it will be better to look into our website. Will show them all the houses that were built with innovative building materials, so that they can have a variety, you know, not be streamlined. In my opinion, I'll advise students to go extreme in design. There's no limitations, as long as they understand means of compliance as is written on SANS 10400 AZ4, means of compliance. If they can comply to the rational design, Agrima certification, rational assessment, deemed to satisfy, then they're good to go.
No, thank you. Yeah, so I think do visit the NHBRC website, lots of resources. If you have time, there's also a very interesting building test site that is in Soshanguve that can be visited. I think the details are also on the website, aren't they? Yeah. So north of Pretoria. So plenty of resources. Yeah. So thank you, Isaac. I'm looking for questions. Where's the chat? Has anyone put anything in the chat?
I've just made a post to the chat. There was a question last week about a plan of an RDP house, which I've added to the share folder. And then also, while we are updating the webpage for the competition with videos and some of the PDFs of the presentations, you can access the Google Drive folder here. We should have the rest updated onto the CIB competition webpage within a week. So that's the only chat at the moment. It seems everyone might be hard at work at their projects, and they don't
maybe they're already halfway through. They don't want to hear any new ideas in case they have to change their designs. So.
Yeah, maybe ideas are so crazy they don't want to comply with aggregate certificates, and that's fine as well. That's fine as well. One of the large prizes is the sponsors prize. I think the second largest prize, monetary value, will be chosen by the NHBRC. But of course, you can go crazy. You can comply. All ideas and all submissions are welcome. I know last year we were pleasantly surprised by projects that complied and projects that were way out and crazy ideas.
Okay, I think maybe the last couple of things. I think, Francine, maybe just remind everybody just exactly about the process, just in case people have come in.
I'm expecting that your lecturers will start contacting me asking for numbers. So you will each receive a 3-digit number from your lecturer. If you are from a university where your class isn't taking part and your lecturer has other work or other competitions that they are focusing on, then you can directly contact me for a code on the web, the email address, CIB City Center, the competition Gmail address that is on the brief. You can contact me and I will give you a number. Please do not place your name or your institute on your submission, just this number. Then I will also give you a form to fill in where I will ask all the details of all the group members to be submitted. Then you don't have to worry about printing. We print. I'm just asking that when you submit, please submit a PDF. If you make a mistake and submit something incorrect, I'll probably just mail you and say, hold on, this is a TIFF, I can't open it, please send me a PDF. So we want as many submissions as possible. So we're going to be on your side. We're going to try and assist you as far as we can to getting your work printed. Then we will announce 12 finalists before we travel down to PE. And then your submissions will be presented at a conference in PE and the winners will be announced. And you will find out, you're welcome to attend the evening as well if you are a finalist, but you will probably find out from me on the night, and then you will receive a digital certificate for each member of the group. Do I have any questions with regard to the submissions?
All right, no. There is a chat
question.
Okay, so Nozipo, I understand that the design is highly conceptual. May I ask how much of the structural resolution is expected to be shown?
It's an excellent question. Jeremy, do you want to go first or shall I jump?
Okay, let me go first. The way we've conceptualized this competition is that we've got a first, a second, a third prize. And what we also then have are very specific prizes for very specific aspects of the design. So in terms of the way you approach it, you can decide you're either going for an overall first prize, or you can decide you're going for a materials one, or you're going to look at a specific area. And what you then do is you find the key kind of conceptual issues that you want to tackle, and you use that to prioritize the way you design and the way you present your work and your competition entry. So what's quite important is to think through the prizes, and do it that way. So that's the first thing. The second thing is that it is an ideas competition. Okay, so it's about new departures, different ways of conceptualizing human settlements, housing, because we need different models. So that's the first principle, is that we would welcome new ideas, different ways of doing things. The second part to that, it mustn't just be new and different for the sake of it. It must be new and different because it works better. It's more sustainable. It's more aligned with social needs, human rights, which is what Isaac talked about. And the second part of what you need to present is the evidence, the methodology. And that's very much what I presented last workshop. And so if your issue, your concept is about bio-based structures, you then may put a huge amount of detail into bio-based structures and show how these work and how they work far better than, you know, concrete or a steel structure or a masonry structure. So what you then do is you position yourself very well for maybe, you know, one of the particular prizes around materials. So there's no kind of very hard and fast rules. What is important is it's innovative, it's unique, it adds, you know, a huge amount of value to thinking about human settlements. B, you prove it, you follow it with enough rigor to really think through the design and do it very thoroughly. And then C, you show the evidence. You know, you show physically how you've got into it. If necessary, you compare it against 2 or 3 other types. You know, there's a lot of clues in the brief, a lot of clues in the workshops, and you use those, and you pursue it, you know, and put it all together as a very clear presentation. So that would be my response. Francine?
Yeah, no, I agree with absolutely everything you said, Prof. Jeremy. From my side, I'll give a few thoughts on insights on the judging. Seeing as I'm not part of the judging, but I watch the judging. And what happened last year is the first prize, the biggest monetary prize, was the best idea by far. And it was beautifully presented. Was there technical detail to it? No, there was no technical details. However, it was believable. They built a model. And the structure of that model, the judges believed that this structure will stand, that it was believable. Then the second largest monetary prize was the NHBRC prize. And that was an extremely detailed proposal. You could see where the water go, where the winds go, exact structural system. So it's either or. I think the way you present it and the way you state your case is far more important than knowing exactly where the ceiling board will go or what trim you are using. So, and you only have one A1 sheet. Then the second question here, in addition, do we show precedence and analysis with our conceptual work since we are limited to one page? That's an extremely interesting and very good question. If you show an image on your presentation that isn't yours, it must be referenced. Now, last year, there were very, very few presentations that showed precedence. I think one student showed snippets as well from Sustainable Development Goals. So those are not the students' ideas. And I saw that the judges passed those because a page, or they didn't linger with those. All the submissions were judged. But your ideas are more important than somebody else's ideas. Your interpretation of precedents are more important than presenting precedents, especially if you only have one A1 sheet. So keep that in mind. Then also conceptual work. Like I said, first prize winner was a model, a physical model that was built, that was almost conceptually built, and then images were superimposed and it was presented like that. Another winner, the ecological prize, ecological or environmental sustainability, which was from UCT, one of their images was of a concept model, and then the 3D model as well, showing the development. So that was a very interesting quick take. Some students did put in hand drawings, but poorly done conceptual work. And that also didn't win prizes because page space was spent on work that should have stayed on bump. So if you have beautiful conceptual models, show that sequence very quickly and very small, but focus more on showing your idea, your final idea, because you only have one A1 sheet. And some groups have 6 students in it. So rather show it as though you are selling it and leave, or the majority of the process or the non-properly presented process, keep that for your lecturers in-house as well when you print up in your portfolio exam. That would be my take on it. Prof. Jeremy?
No, I think that's an excellent response. And remember, it's one sheet, so you have to be, very concise. And the judges aren't particularly concerned about how you got to the idea, but what they want is brilliant ideas. They want highly innovative ideas, and they want you to explain them. What Francine said, believable. This thing would work, even though it might be a incredibly innovative idea. There's enough evidence, there's enough detail to convince the judges that this is something that could work. And I think, just to go back to one of our earlier workshops, where we had human settlements, we had Prof. Sijakula, there is an interest in piloting, in modeling. So that's one of the things that will certainly be in the back of the mind of some of the judges, is kind of, would this model be something that we might want to pilot? But I think the question about structure, this is not a structural competition. It's not about it's not about how well detailed your building is. Have you put the DPM in the right place? It's about ideas. So it's an opportunity that maybe you won't get again. Really to kind of think in this blank sheet of paper, and look at the workshop ideas and say, what is the future of human settlements? Or, as architects, how do we want to live? How do we create a really sustainable, fantastic environment that, just works, in all sorts of levels? And imagine that, and then draw it, and then make sure that you provide the kind of evidence that it is what you say it is, and what it looks. Isaac, do you want to add? I think you might have. You got some things to add?
Not really. I'm just want to just add a little bit to say you're not confined to an RDP type size. Remember, there's mixed use design, there's social housing, there's all. So don't be confined to an RDP plan, because the actual truth is that there is no RDP plan. Every province or every municipality, they've got their own typology. So you are free, as long as you stay within, when we talk about, they even call them BNGs now, no longer RDPs. So your creativity should not be limited by that box house, 2-bedroom. No, create a living condition sustainable enough to your ecology, the culture, and the conservation as well. So you're not limited to the typology of an RDP housing. So in Cape Town, for a good example, they're building mixed designs. You've got shopping centers, office blocks, then you've got your residentials. You come to smart cities. I made example that look at your smart cities, how they are sustainable human settlement, how people starting to move and live. So look into those things. Right now, I won't ask for any calculation of anything. for any material. All we need is the concept, the design concept, and how it works.
Agreed.
I know. Thanks, Isaac. That's a very useful input.
So if anybody watches this video afterwards and they have questions, then send an email, and I will answer. If the question is interesting, I will answer to all the schools. So, and distribute the information like that.
Yeah, I should think while you're still there, the emails must come to you. This must not email us directly.
Yeah, email.
Going to be here.
Correct. That's quite important. So I think, as Francine mentioned, the way we run this process is that Francine is the kind of link for all communication, all answers, and she'll be fair and she'll make sure that everybody has a good chance. All the judges are totally separate from that process. And what the judges see are the A1 sheets with no markings on it. So they have no idea who's developed them. They've absolutely no understanding of where they've come from. And what they do is they work independently. So all the different judges work independently and rank the different submissions in terms of the prizes. And only after that do they then look at to see if there's alignment between the judges. So it's a very transparent, extremely fair process. In journal articles, they have what's called a blind review. So you don't know who the author is of a scientific paper, and it might be a Nobel Prize winner. You're still going to criticize it, and not, you're looking at the content, you're looking at the detail, and you then give that response. And that's exactly the process we run. So it is a blind review. Judges don't know who it is, and only right at the end, once we've got the numbers, we give that to Francine. Francine then can then rank and actually state who the winners are, and we won't. The judges won't know who the winners are until right at the end.
Yeah, and if I get hit by a bus, a representative from the CIB will also know which submissions goes where, and will have access. So. Yeah, and one last thing from me as well. Submit. Don't think your project isn't good enough. Don't think that your idea isn't good enough. Submit. There's such an array of prizes. You don't have to have the best project. You just have to have one of 12 good ideas. And even better if you target a prize, such as social sustainability or such as the unit design. Yeah, there's enough to be going around. And the audience that will see these projects at this conference, it's international. So this is a platform for you to step into and to take. So yeah, we can't wait to see your submissions. And we are so thankful to you for participating and giving us your ideas. Yeah, so thank you very, very much to the students that are online and those who will watch the video afterwards. I should be more encouraged. Prof. Jeremy, 2 excellent questions from the students. Any more questions from students? Anybody else? Your deadline is the 17th of May. Please submit early from around about the 10th if you can. Once you submit, I'll send you a form to fill in. This is it then. Good luck. The best of luck, students. Yeah. Anybody else, Prof.
Excellent.
Jeremy? Any closing remarks?
No, I think best of luck. We look forward to some very good entries, and I hope you enjoy it. I think, the workshops have been interesting. The brief was very interesting. The site's interesting. So hope you enjoy it. And as Francine said, put it in and have a go.
There we go. Thank you, everyone. This concludes the workshops then. Yeah.
Yes. Thank you. Bye-bye.
Have a good evening, everyone. Cheers, cheers.